The second is quite something else entirely. It's a micro art, an 18 karat gold rocket crafted by Telangana artist Ajay Kumar Matewada, holding three tiny sculptures of Nobel laureate Sir C.V. Raman and visionaries Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam. Each one of them is smaller than a grain of rice, and it's a fitting tribute because all these three names essentially live aboard Vikram-1 itself. The Raman engines, the Vikram-1 vehicle, and the Kalam motors. Now, as we count down, of course, it's worth taking a pause to appreciate where this journey is beginning from. Vikram-1 lifts off from the first launch pad here at Satish Dhawan Space Center at Sriharikota, more familiarly called as the Shar Range, a place that has witnessed some of the most defining moments in India's space program.
That's correct, Suyash. This very pad has a proud history and legacy of its own. This is the exact place where Mangalyaan set off for Mars in 2023. And Sriharikota itself has launched India's greatest space journeys, like Chandrayaan to the moon, Aditya L1 to study the sun. And now, our very own Vikram 1 adds its own chapter on its journey to the stars.
That's right, Akhil. Missions like Vikram-1 are helping position India to serve the fast-growing global demand for small satellites, and they reflect a wider momentum as well. Under national initiatives championed by Honorable Prime Minister Narendra Modi ji, Make in India, Atmanirbhar Bharat, Skill India, this country has been building exactly the kind of indigenous innovation, advanced manufacturing, and high technology skill that a vehicle like this is built on, and which is why today's mission is of utmost national importance.
Yeah, and in some of those initiatives that you mentioned, we also have Gati Shakti, which has essentially eased the way we get approvals and get things done. For what could used to take years on end, now is simplified to a matter of minutes just sitting at home.
अवश्य, किंतु उस तीव्र गति और तीव्र प्रगति का बड़ा भाग एक महत्वपूर्ण मोड़ से जुड़ा है, जो कि 2020 में ऐतिहासिक अंतरिक्ष नियमों के परिवर्तन के परिणाम स्वरूप जो इन स्पेस संस्थान की स्थापना हुई थी, और इस संस्थान का कार्य शासन तंत्र और निजी अंतरिक्ष क्षेत्र के मध्य एक समर्थ, सुगम और दूरदर्शी सेतु की स्थापना करना था, जो कि काफी कठिन कार्य है। और स्काईरूट जैसी सभी संस्थानों की ये यात्रा को सशक्त और आधार प्रदान करता है। इसीलिए हम इन स्पेस के प्रति हार्दिक कृतज्ञता व्यक्त करते हैं।
That's right. We have live on our screens views from the launch gallery where hundreds of students, actually thousands of students, have joined us on this historic mission. These are the people who are the future of our nation, and we encourage them to take up projects in future which contribute to the space sector and the national space ecosystems as well. Now that we've explored the significance of today's mission, let's take a closer look at what Vikram-1 is about to do in a few minutes. Of course, Vikram-1 will lift off and ascend vertically from the launch pad before executing a pitch-over maneuver, and from there it will gradually transition into what's known as a gravity turn.
That sounds a little counterintuitive, and if the launch vehicle is headed straight to space, then why does the rocket just keep not going straight up?
That's a great question, Akhil. While gaining altitude is
Skyroot
important,
LCC to all
reaching orbit is
automated
all about
launch
building
sequence for
horizontal
mission
velocity.
Aagaman
The
initiated.
gravity turn allows the rocket to efficiently accelerate around the Earth rather than simply away from it, using less propellant while achieving the velocity needed for
Event
orbit.
number 104.
Yeah, and
Completed.
we've just heard callouts from the Mission Control Center that the
Roger.
automatic launch sequence has been activated. It's one of the preliminary starts to the program and a very important point. At this point, the countdown is now fully automated with hundreds of onboard commands executed in precise sequence, leading us to liftoff.
And although the process is entirely automated, I believe the mission teams are closely involved, right? They have to ensure that every system is operating at its nominal health conditions.
And correct, Vaidehi, if any one of the many critical parameters that we observe in during the entire sequence goes out of its normal expected bounds, then the rocket smartly aborts the entire sequence and initiates a preloaded set of commands, and that will safeguard the entire vehicle. And then the people stationed at the ground or the engineers can have a closer look. And if the issue can be resolved within the stipulated time, then we'll have the sequence back again and we can go ahead with the launch.
Yeah, that's right. This is something very useful to have wherein engineers can resolve faults and understand if there's something that can be quickly fixed, and then we can continue back on ALS. So I think we were just talking about what the rocket does, and once stage one powers the vehicle for nearly 100 seconds, something important comes, which is max Q.
Right, you're right, Suyash. As the vehicle continues to pitch over and accelerate, it approaches one of the most demanding phases of ascent. Nearly 25 seconds into the flight after the gravity turn is max Q, the moment of maximum dynamic pressure. This is when the rocket experiences the greatest aerodynamic loads, a true test of its structural strength and engineering precision.
Yeah. So now we're at T minus 9 minutes and we're entering another crucial phase of the launch countdown. The launch team is now carrying out a final series of vehicle health checks and making sure that Vikram-1 is fully prepared for flight.
Yeah, as we can see on our screens, one of the most key milestones at this stage has been completed. That is the transition from the external ground power to the rocket's onboard batteries. Up till now, the vehicle has relied on its own ground support systems, but from this point forward, every stage must successfully power itself. And engineers are closely watching the battery performance and electrical health to ensure that this transition is very smooth and every system remains entirely stable.
Right, Akhil. With the power transition complete, attention would shift to the rocket steering system. Engineers will now be verifying that the thrust vector control, or the actuators as we call it, the mechanisms which steer the rocket by precisely directing thrust through powered flight.
Yeah, and you mentioned these actuators. Essentially, all of our solid rocket motors are equipped with what is known as a flex nozzle control. Sounds like a big complicated term, but it's quite
Indeed.
simple. It's just the nozzle is capable of swinging in two planes, and the way we achieve this motion is by using electromechanical actuators. So you might imagine that this is something very important that we should check. So what engineers do is they perform something known as a null check. Essentially, they currently try to hold the nozzle in a neutral position. And then once that is confirmed, they provide small commands to the nozzle to deflect it. And if the response is deemed to be normal and the position is correct, we can be rest assured that the rocket will obey every command that is issued to it by the guidance computer. All right, live on your screens right now is the Vikram-1 rocket. And for a long time now, we've been looking at these views, and the biggest thing that comes out to our mind is, wow, that's a marvelous piece of engineering. And it's actually rocket science, right? There's a nearly 1,000 systems that need to work in perfect synchrony just to make liftoff happen. And that's 2/3 of all systems on rocket. So 2/3 of all system on the rocket need to work perfectly to make liftoff happen. And while it's so easy to look at the rocket and be amazed by its beauty, we would like to take a small pause and focus on the fact that behind every bolt, every wire, every line of code that is on the rocket today, it's been built by people. People whose passion, perseverance, and dedication have made this moment possible. Of course, a launch vehicle is never built overnight, and it's the result of countless people obsessing over one thing to make it perfect.
Exactly, Suyash. We often celebrate rocket launches, but rarely appreciate the engineering complexity behind that. And the most primary guiding principles in Skyroot is our people are our thrust. So it's not just the rocket alone that pulls the company up. It's just the people that pushing forward, pushing the entire technology forward, and all that hard work. So Vaidehi, after working on an orbital launch vehicle yourself throughout these years, what has been your biggest realizations in designing the rocket?
So one of the most important realizations which I've had is, as Suyash also mentioned earlier, Rocket consists of almost around 1,000 independent subsystems, and they are deeply interconnected. A seemingly small error
T
in
minus
one
5
discipline
minutes.
can propagate through multiple
observed.
subsystems and ultimately jeopardize the entire mission. Rockets operate with extremely tight margins, so local design inaccuracies rarely remain local. This interconnectedness is precisely what makes launch vehicle design both extraordinarily challenging and intellectually rewarding. Each deviation might appear acceptable individually, but they can also collectively they can all consume all the design margins available.
Yeah, so we have a planned hold at this point. As you might see on your screens, the timer is paused at 5 minutes. So we will be checking with the internal teams, and we'll get back to you with the countdown shortly. All right. While we wait for this countdown to resolve, there's so many cool facts about space, and something really fascinating that always catches me is when Vikram-1 races through the atmosphere, it's not just fighting gravity, it's also battling extreme aerodynamic heating. And one thing that's always curious is why is the rocket heating up while it's going up in the atmosphere?
Right. So, as we are accelerating into the dense atmospheres of Earth with velocities almost 3 times, 4 times that of sound, the air in front of the vehicle rapidly gets compressed, and just outside the vehicle surface will have extremely high temperatures, which then get convected into the vehicle surface. So, just a simple question: do you guys know like what is the heat flux which we face standing on the Earth's surface due to the Earth's radiation?
I think 1000 watt per meter square, kind of. Am I right?
That's right. That is 1,000 watt per a meter square. It's around zero
There is
point
a
0.1
hold
watt per
and
centimeter
countdown.
square.
Request
When
all
Vikram
people
1
to sit in
ascends
their
into the
places.
Earth's atmosphere, its nose strip can face around 15 watt per centimeter squares of heat flux.
That's pretty large. I mean, as compared to humans, if we, yeah,
That's
on
right,
Earth.
that's right. And we really need to design a thermal protection system to keep the structural design under the set constraints. If we don't design any thermal protection
There is a
system,
hold
the
at T minus 5
vehicle
minutes.
surface might
Request all
end up
people to
going to
be in their
1500
places.
degrees Celsius. And
Control to all stations. There is a hold observed at T minus 5 minutes. All stations are requested to be on standby mode.
We have received confirmation that this is a planned hold and we've been advised to stay on standby. We will communicate regular updates to you, so please stay tuned with us. Can you check if they can queue us and we'll talk trivia? Change कर दो. Change कर दो. Trivia वाला खोल दो एक बार. I don't know if the last trivia went through. एक second time लगेगा, रुक जाओ. So just for safety sake, we'll do the next trivia, which is hold Kalam. Kalam like the names. वो already बोल दिया ना. I don't know if it went through, so I don't want to repeat. Okay, okay. क्या बोलेगा तू? क्या बोलेगा? ये कलाम वाले से. पर मैं already हिंदी में तो मैंने बोल ही दिया था. Continue now. As we were talking earlier. Ask them to show commentators and QR mics. We'll continue.
Basically, you just pan the live camera to the commentators. They'll just talk to the audience.
नहीं भाई, मैं ये already बोल चुका हूँ. APJ कलाम सर का.
That's okay.
I'll start igniter meet solid versus not solid. Nozzle flexing पे बोल दूँ क्या? तू बोल. मैं बोल.
करूँ मैं?
नहीं ये
ठीक है।
इसमें direct
should I ask estimated time?
नहीं नहीं छोड़ रहे।
You are able to inform me?
Hmm.
Yes.
All right. Another fun fact while we wait for this hold to resolve is we always take pride in naming our hardwares, and most of them have been in honor of some exceptional minds. So, Akhil, why don't you tell us about some of our naming conventions?
Yeah, I mean, if you can see in the rocket itself, all our rockets and the launch vehicles are named in the honor of Dr. Vikram Sarabhai, the very like father of Indian space program we call him, and all our solid rocket motors, their names are dedicated to Dr. APJ Abdul Kalam, our very own missile man, and all our cryogenic engines, we have dedicated the names to Dr. Satish Dhawan, which we are like the center we have also Satish Dhawan Space Center dedicated to him. And then we have our hypergolic engines, Raman. And then we have dedicated that name to Nobel laureate Dr. C.V. Raman and our mission computer after the renowned mathematician Srinivas Ramanujam.
So yeah, I think we're gonna keep up this idea of naming our hardwares after scientists.
Until we run out of scientists. Yeah.
Yeah, so I think
Not the hardware.
we need the young budding viewers who've joined us in the launch gallery to become scientists themselves and famed scientists who take India to great heights, so that we may have names.
Yes, right now, maybe. Coming to one more interesting fact, I think a lot of people they don't know this. Like, if you look at a launch vehicle, it seems pretty rigid at first. But the interesting fact is when the entire rocket, when in flight, it experiences combined effect of aerodynamic loads, engine thrust, wind gust, and due to different steering maneuvers, the teams or the designers deliberately give some flexure or like they make rockets slightly less rigid so that it can actually bend along its length throughout the flight. This is intentional, that designing an absolutely rigid rocket would make it significantly heavier and less efficient. And it also creates a complex engineering challenge. As the structure bends, the onboard sensors can detect these motions, so the guidance and control system must distinguish the rocket's actual altitude and structural flexing to avoid unnecessary control corrections. And engineers carefully predict these bending modes and their natural frequencies through the structural dynamics and aeroelastic analysis, ensuring the vehicle remains stable even as it flexes its way through one of the most demanding phase. And this flexure could go up close to 10, 10 centimeters, I think. Yeah, close to 10 centimeters. That's pretty huge.
That's right, Akhil. Something for the kids who might be, looking at this live stream. So, rockets don't just fly, they keep falling around Earth. It might be difficult to imagine this, but people often imagine astronauts escaping Earth's gravity. The truth is, gravity never lets go. Even the International Space Station is constantly falling towards the Earth, but it's moving sideways at so high speed that it keeps missing the ground. And that's what we call as orbit.
Yeah, that's wonderfully put.
Orbit is a state of perpetual free fall.
Yeah,
Wow.
that's right. And you spoke about how astronauts on the International Space Stations are also constantly falling towards Earth. And with us today in the Mission Control Center is our very own astronaut, Shubhanshu Shukla, and he's been following Skyroot's journey from a very close distance. He's part of our family as well, and he's here to cheer us on. So we thank him for his presence.
One more interesting fact for our viewers that rockets get lighter every second. Unlike an airplane, a rocket becomes lighter every second because it continuously burns and throws away propellant. Because in aircrafts we have air breathing engines,
this vehicle
so
directed
the
to all stations.
oxidizer itself is the air
The
that
reason
the
for hold
turbo
has been
fan sucks in.
identified.
But when
And
you have
resolved.
a
We'll be
rocket,
reinitiating ALS soon.
when you have a rocket, you
after
cannot
finalizing on
have.
a T0.
Yeah. So when we are dealing with rockets, there is no air outside air can enter and can be utilized for propulsion. So we have to carry our own bottles of oxidizers and fuel. And once the rocket is ignited and it's on its way through the entire flight, the propellant is expelled. And when the stage gets burned out, it's also thrown away or jettisoned. So that is why rocket keeps accelerating because there is less and less mass to push.
That's right, Akhil. A rocket may weigh hundreds of tons on the launch pad. Consider our Vikram-1, it weighs around 45,000 kgs on the launch pad, but nearly 90% of that weight is just propellant.
That's really amazing. That structural mass is so less. I mean,
The views on your screen are from the launch gallery at Sriharikota, and we have thousands of students who've joined us from all over the nation, and they're eagerly waiting the launch of India's first privately built orbital launch vehicle, Vikram-1. And of course, like I mentioned earlier, it's a test flight, and we'll be doing a few of these before we move into routine commercial operations. We are in a state of hold for now. For the viewers who've just joined us, we have successfully initiated the automatic launch sequence at T minus 11 minutes, and a lot of the key events that went into this have been executed. We have a hold right now at T minus 5 minutes. And just to recap, we've had the switch over to internal power, wherein the vehicle is now powering itself. All of the null checks on our actuators have been completed. So essentially, the vehicle's steering systems are in great health. And we're at a planned hold. One quick look at the rocket as well, standing on the launch pad. All right, we're getting updates from the mission control teams. The hold that you observe on your screens was due to a hold raised by the navigation team.
Vehicle directed to launch
Where
control. Please do the needful pre-exercises to reinitiate ALS and confirm your readiness.
and
Copy.
we've gotten confirmation that we will be starting ALS shortly, so please stay tuned. So we had a planned hold, and we've just heard um, from the mission teams below that we are ready to restart the automatic launch sequence shortly. And Just to recap once again, Vikram-1 is on the launch pad. It's ready and eagerly awaiting its first test flight. We've had the initiation of the automatic launch sequence, and through that, we've completed the internal power switchover, which means the vehicle is now powering itself using its own batteries. We've also had the null checks been completed, and we're now waiting for the next window to come about for the ALS to restart.
So now that we know that the ALS is on hold and soon we'll be back with a new time and the restart of ALS, let's talk about the entire journey of Vikram-1, the mission sequence. Now we know that first 100 seconds of the flight, the stage 1 will power the rocket to the denser layers of the atmosphere, and exactly at an altitude of 53 kilometers at 103 seconds, the stage 1 burnout will happen and the stage separation will initiate. And after that, the stage 2 will ignite and it will power the rocket through the thinner layers of the atmosphere while keeping the same level of acceleration. That is the point. And later on in the stage 2, during the stage 2 burn duration, later half, you have the payload fairing and it separates, and this is the first time when the payload or the satellite is exposed to the atmosphere or to the space, the higher layers of atmosphere, which is exactly nearly close to space.
Yeah.
Having protected the satellite throughout the ascent, that the fairing's job is done.
Yeah, that's right, Akhil. And you mentioned that the PLF, or the payload fairing, is the portion that essentially protects the satellite from the difficulties of the environment that the rocket goes through. The question then becomes, how do we separate all our stages, right? So we use something which is very unique, and we're very proud of that. In-house to Skyroot, we
Vehicle
have
director
the
to control,
separation teams
please set the
which
T0
have
as
developed
1205,
a pneumatic
30 seconds.
ultra low shock mechanism, and the whole goal of this
Control to
mechanism
vehicle
is it
director.
relays very
Confirm
little
the
shock
T0
to the
as
payload itself.
1205, 30
So
seconds.
the
Roger.
the payloads usually carry very sensitive
Noted.
electronics and instruments. So if you have
Control
a shock
calling
event
timing.
come about, it may
Timing,
damage
yeah, please
some
go
of the
ahead.
sensitive instruments.
Timing, you can
So that's
set
why
the
we
revised
specifically
T02
made it a point to develop
12:05,
this
30 hours
pneumatic
IST.
ultra low
Okay.
shock separation mechanism.
Like, for the knowledge of our viewers, I would also like to reiterate most
You can
typical
set and
rockets,
hold
they
the
use
count on
pyrocords, which use
Timing,
explosive
Roger.
charge to shear out the bolts and separate or jettison the entire stage, which could be catastrophic for some sensitive payloads. That is
Yeah.
very costly and could be like, you might
Timing,
lose
calling
some data
control.
from the satellite and
Yeah.
affect its workability.
Control here, go ahead.
Definitely.
Still external hold mode is coming.
Right.
Noted.
Now, even after the payload fairing has separated,
director to launch
the job
control.
isn't done yet, right? The climb is
Please release
still
external
going
hold.
on. Stage 3 steps in, and it generates quite a
launch
large
control to
amount of
controls.
thrust
External hold
to
release.
essentially power the vehicle
Roger.
into orbit. It keeps pushing it to near orbital velocities.
Control.
And then
Request
comes
MCC
something
to
different,
release the
like we
hold.
talked about earlier. We have the orbital adjustment module that kicks in. And this is the stage that I got to work on very closely. Like I mentioned earlier, it was a team of very ingenious, multidisciplinary members. We had teams from systems, propulsion,
Timing, you can
dynamics,
set the revised T02
quality,
12:05,
safety,
30 hours
reliability,
Timing
CFD, design. I mean, you cannot count these fields on the fingers of your hand, and they all had to work in unison
Control
to
to all ground stations.
build this stage.
All ground stations to
And
know.
then once
Revised
it starts
T0
working,
is
it
at
will precisely
12:05,
place
30 hours
all
IST.
of these satellites into its intended orbit. And you might feel like all of this is happening. There's so many things happening, right? But it's just 16 minutes. That's all it takes.
It's so
T-minus 20
fast,
minutes.
but it seems really long. Like, it took us like 1 hour from the entire bus stand to reach Sriharikota. But as Suyashu pointed out, so it's such a we can say the entire rocket engineering, the complexity. Looking at the complexity of it, it's like an entire opera house. You have to be like a soprano. You have to be so perfect. Every system, every individual, and every component should be in in tune to engage all the systems at the right moment so that we can have even a small ignition. And now we have a Vikram-1, which has close to 1,000 subsystems, and almost 2/3 of it will be utilized just even at liftoff. That's really fascinating.
So we've gotten confirmation, and you might see it on your screen shortly as well. The countdown has restarted. We are resetting to T minus 20 minutes, and we are at T minus 19
Vehicle
minutes
directed
for the
to Skyroot
information of
CNC.
all our
Please
viewers.
inform other ground stations about the new T0. Please
To
confirm on
control
that.
timing in external
Skyroot
hold mode.
CNC copied, new PGM files shared.
Roger.
Timing to control timing in external hold mode.
Roger.
Skyroot LCC to all, S2 and S3 HMS is event number 97 completed.
Roger. Control to LCC, MCC and RSO. Please note timing confirmed, external hold mode.
Skyroot LCC to all station. New T0 is 12:05:30 seconds.
All right, we're hearing from the mission control that the new T0 time or the liftoff time for
T minus 18
mission
minutes.
Aagaman is reset to 12:05 p.m. So stay tuned. We'll be with you, and we'll give you some more space trivia. We have a lot of those, and we'll also take you through the journey of the rocket as well. You know, many of the times, one of the question that comes is why space? You know, it's so hard. Getting to space is hard enough. Getting to space on the first try is even
All
harder.
stations to note.
So if
Mission
it's so
Director
hard,
authorized the launch
why do
of
it at all?
Vikram-1 mission Aagaman.
What does it hold of such huge importance that we want to strive for making to the stars?
I mean, if you think about it, all the activities that happen on Earth, they are connected in some or the other way to space. Space has quietly become a part of our daily life. Every weather forecast, every map that guides us home, every digital payment and long distance call leans on us. It all leans on a satellite somewhere overhead.
And I mean, it's like the human curiosity that takes you really farther. And like humans, we actually like complex things, and we just it's not just enough to stay on one planet. And so that's why the man decided to take a decision to set off to some higher
Skyroot
horizons.
CNC to
And
mission
it is
director requesting
still,
to
after
reiterate
80,
the
90
new
years, the
launch
complexity still remains so high
launch
in
height.
space travel.
Yeah, and one question that comes about is how do you make all of that happen?
The new launch IST
So-
is 12:05:30 seconds.
Right,
Copy.
we've just gotten call out and confirmation
Skyroot
that the
CNC
new
confirmed.
T0 is
New PGM
12:05
files have been
p.m.
shared with external
Just as a
stations for the
reiteration
same
to all our viewers.
Roger.
So we were talking about what it takes to make all of these happen, and of course we would like to thank ISRO for all their support, from opening the doors to the Satish Dhawan Space Center, the historic first launch pad, issuing us guidance and helping us with all the nitty-gritty details. They've worked with us day and night on this. They've treated this vehicle as though it were their own, and they're so committed to making sure that mission Aagaman reaches its intended orbit, that they've essentially become a part and parcel of the Skyroot family.
They treated the
minus
vehicle as
15
their own,
minutes.
as you correctly said, Suyash. Like, they have been involved with us throughout the entire campaign,
Vehicle director to
helped
Skyroot Launch
us,
Control.
and along
You
with
can
ISRO, we would
initiate
also
a
like to
automated launch
take a
sequence
pause
at
to
T minus
thank
11
in
minutes.
space, and they have acted as a bridge between the government organization, facilitating all the review meetings, everything, and allowing us access to SHAR, all the policies, all the reforms. So thank you in space for all the efforts, and thank you for rooting for Skyroot.
Yeah, one interesting thing, and this is a personal experience as well. We did Mission Prarambh in November 2022, and believe it or not, the headquarters of InSpace were inaugurated in June 2022.
That's just 6 months from our
Yeah.
first launch.
So you might have to imagine that it's just 6 months, and they've had to imagine and they have to write and draft all the policies that are required. They have to make sure that they
T
know
minus 14
how
minutes.
the mission is going to be, regulated. What do we need to do to essentially handhold the space sector, the private space sector?
It was very seamless, indeed, very seamless. The way they took all of it.
Yeah, very true. It definitely is not an easy job, and they've excelled at it. Same goes with ISRO. We've had, cases where they've been chasing after us.
Yeah. I remember those days.
Yeah, and it's quite, empowering to know that the government is playing such a huge role in helping make this happen. We talk about Atmanirbhar Bharat, we talk about Viksit Bharat 2047, and all of these technologies, what the private sector is trying to build today, is essentially contributing to that goal. If we want to be the world leaders, we need to start now.
Exactly, Suyesh. Like, I was fortunate enough to visit the LPSC test facility when I was with the Raman-1 test campaign. It was a very great experience. I mean, and the coordination with ISRO teams and the way they facilitated the entire test campaign and the data analysis, and post-test the data came like really fast, and like they were after us and they were very patient with us. So yeah, that was a really great experience for the young engineer like me.
Yeah, and that sort of reminds me to the stage test that we did just a couple of months ago. I think nearly 9 months ago.
Yeah, around I think October.
Yeah, October, I think. And so that was the test of the orbital adjustment module. It was a all-inclusive test. We had the entire stage. We had all the engines, the thrusters. We had the avionics. We had something quite interesting
T
and
minus 12
melodic
minutes.
as well. We played Sare Jahan Se Acha using the Raman Mini thrusters on the stage, which was something very unique, very captivating to the young minds. Many people did not think that you could play music out of the screeching sounds of 50 Newton Raman Mini thrusters.
Again, an opera, I told you, right?
Yeah, definitely.
Before that, yeah, you say this. Just give me a go. When to say. Just give me a go when to say. अभी तो हम pause है ना.
Do one thing. Let it go into ALS. We'll give ALS command. तो 3 बार बोल दी कि आप छोटे power में.
T minus 11 minutes.
उसके पहले फिर ALS का introduction. Your point ground stations are ready. Yes. And this is 9 minutes. 9 minutes to do.
Automated launch sequence initiated.
Roger.
All right, we're at T minus 11 minutes again, T minus 30, 10:30, sorry. And the automatic launch sequence has begun. We are in the pre-checks phase at the moment, where all the teams are essentially checking the health of the vehicle once again, making sure that all systems are operational and go for launch.
Before that, we had one confirmation that all the ground stations supporting today's mission, they have
T minus
completed their
10
readiness
minutes.
checks. As the vehicle travels downrange, telemetry will seamlessly transition between multiple ground stations, from Shah to Port Blair, then Bogor in Indonesia, and then finally Yatharaga in Australia. This network ensures continuous communication with the launch vehicle, with all mission data relayed back to mission control in real time.
That's right. And just to recap to all our viewers, some of the callouts that have happened till now. We first had the acquisition of day of launch winds, which is we acquire using a Doppler weather radar the winds prevalent. And as Akhil mentioned earlier, it's slightly a cloudy day today for launch, but come rain or sunshine, we are always ready to launch.
Yeah, the rain can't stop us, I think.
Yeah. And the next thing that we managed to
T
do
minus
is,
9 minutes.
of course, the guidance teams have completed the static navigation profile as well as the gyro compassing of the lens package. So this is kind of the sensor which tells the attitude of the vehicle, essentially tells you how you're oriented with respect to Earth. And it's something very important that the vehicle has to do. It needs to know where north is and where the direction of gravity is. Post that, like Vede, he just confirmed, we've had all the ground stations. We have 4 ground stations supporting us today. Shar, which is where we are coming to you live from, and then we have Port Blair, following which we have Bogor in Indonesia, and finally the Yatharga ground station in Australia. So all of these ground stations essentially capture telemetry, which is the data from the
T
vehicle,
minus 8 minutes.
and relay it instantaneously to us.
Yeah, Suyash, you were mentioning about how we also see the wind profiles. The wind profiles are also checked. Just a while back, they were checked. And as I can see on the MCC, this wind profile or this data of the winds is also going to be uploaded into the Mission computer in the sequence that is coming up. And also, one of the key milestones which have been completed is the transition from external ground power to the rocket's onboard batteries. The vehicle has relied on ground support systems till now, but from this point forward, every stage must successfully power itself. So engineers, I believe, are watching the battery performances and electric health right now to ensure that the transition is smooth and every system is remaining stable as of now.
And for this
T
ALS
minus
sequence
7
also,
minutes.
we have completed all the null checks for all the stage nozzles, and the FNCs are working as fine as possible. And we are also happy that Dr. Jitendra Singh, Honorable Minister of Space, is joining us live on video call, and he's rooting for Team Skyroot.
We are at T minus 6 minutes and counting. For the viewers who've just joined us recently, on your screens right now is the Skyroot Launch Control Center situated at Shar. We have many engineers looking at the vitals of the vehicle. This includes different teams, starting from
T minus
avionics,
6 minutes.
guidance, navigation, control, liquid propulsion, solid propulsion, safety, reliability, quality, and of course our IT teams as well. One of the things that has also been completed just now is the uploading of the mission computer init files. And that's a funny name of sorts, but it essentially means initialization files. These are essentially files that contain all the requisite parameters to tell the vehicle what it needs to do in the early ascent of flight. And it adjusts for the day of launch wind profiles that we talked about. It also has the gyro compassing
T minus
details
5
within
minutes.
it.
And now we have confirmation that mission computer mode has been successfully changed to flight mode, and we are really jubilant, and everybody is really happy that this stage has been successfully transitioned. And now we'll move towards the next check, that is HMSA disarming.
As we enter the final few minutes of countdown, another key safety milestone is underway. The head mount safe arm mechanism will be activated in a while, and till now it was ensured that the ignition chain has remained safely isolated.
That's right, Vedi. For the viewers who are very curious for this, the head mount safe arm mechanism, which we refer to as
T minus 4
HMSA,
minutes.
is a safety device which is well mounted at the head of our solid rocket motors. And the whole job of this device is to safely isolate the pyrotechnics from the rest of the solid grain. And the reason why we do that is for safety, to prevent any accidental ignition from, let's say, lightning strikes. We do have a cloudy day today, and of course, we have lightning suppression systems. We have 4 lightning towers on the first launch pad. But there can also be some form of electrical runaway. There can also be static discharge. So to safeguard all these devices from electrical discharges, we have a mechanical separation between the pyro devices and the solid rocket motor.
Right, so yes. So till now, the ignition system,
T
it
minus
was
3
in
minutes.
a protective, non-firing state, but now it's going to move on to a state wherein once the mission computer gives the ignite command, it can initiate a pyrotechnic chain of events.
That's right. And we're at T minus 3 minutes, and we have confirmation that the stage 1 head mount safe arm mechanism, or the stage 1 HMSA, has been successfully armed.
This basically means that our motor is now ready to ignite.
That's really great to hear. Along with this HMSA safety mechanism, we have one more layer of safety, which we call the FTS or the CDS, Command District System, or the Flight Termination System. This is utilized when if the vehicle during its flight mode tries to or like deviates from its intended flight trajectory, then the range safety officer can take a call to destruct the vehicle to safeguard the resources around it.
T minus 2 minutes.
That's right. As is with the case with any launch vehicle, we always prioritize safety. And with that in mind, we have all of these systems set up on the vehicle. We are now entering to condition the liquid stages on Vikram-1. So the orbital adjustment module is now conditioning itself and preparing for liftoff. So we are nearly at T minus 1 minute,
All stations
and
stand by for the
we
timer.
will leave you
T
with
minus
the
1 minute.
views of Vikram-1 and join you shortly at liftoff.
Minus 55 seconds. Minus 50 seconds. Minus 45 seconds. Minus 40 seconds. Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds. Minus 20 seconds.
Minus 20 seconds is the call out now.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
And we have liftoff of Vikram-1, India's first private orbital launch vehicle.
Normal.
And we have great views coming from the
Plus 10
tracking
seconds.
cameras. And isn't this quite something?
विक्रम-1 ने अपनी उड़ान भर ली, प्रथम चरण का प्रज्वलन प्रारंभ हो चुका है। विक्रम-1 ने प्रक्षेपण पथ को लांघकर आकाश को भेदने का निर्णय ले लिया है, एक ब्रह्मास्त्र की तरह।
That's very true, Suyash and
S1
Akhil. I am
performance
awestruck
normal.
at the sheer power that stage 1 is producing.
Plus 30
With
seconds.
this, we have two of our major prime mission objectives completed, which was successful ignition and safe tower clearance.
That's right. And we're coming up on max Q now, which is the period of maximum aerodynamic pressure, where the vehicle faces its largest aerodynamic loads as it flies through this zone at Mach 1.5 at an altitude of nearly 9 kilometers.
विक्रम 1 ने सफलतापूर्वक मैक्स
Sharwan
क्रूज
Minato.
क्षेत्र पार कर लिया है और
Plus 1 minute.
Short to main auto.
दल काफी उत्साहित है इस समय और विक्रम 1 प्रथम चरण के आगे बढ़ रहा है और हमें श्रीहरिकोटा व पोर्ट ब्लेयर पृथ्वी स्टेशन से मजबूत दूर संकेत मिल रहे हैं जो
S1
बहुत ही
performance
अच्छी
normal.
खबर है.
That's right. We are at a downrange distance of 22 kilometers with an altitude of 34 kilometers. And on your screens right now are excellent onboard camera views from the vehicle.
And we can also see quite nominal chamber pressure values on the MCC screen.
The vehicle is currently at an altitude
And-
of 50 kilometers.
और यहाँ पे प्रथम चरण का प्रतिकरण हो चुका है और द्वितीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
This is quite a major
S2 motor
achievement for the
ignited.
nation, with the vehicle successfully
Plus 2 minutes.
separating stage 1 and the ignition of stage 2 as well.
द्वितीय चरण अपना सफलतापूर्वक कार्य पूरा कर रहा है और प्रथम चरण का दहन अथवा प्रतिकरण समाप्त हो चुका है.
The vehicle is at an altitude of 89 kilometers, traveling at 2.6 kilometers per second. Of course, our target velocity for today is 7.6.
S2 performance normal.
We've just heard call out that the S2 performance or the stage 2 performance is nominal.
ये एक ऐतिहासिक क्षण है पूरे भारत और निजी अंतरिक्ष यात्रा का.
This vehicle has crossed 100 kilometers of altitude, which is the notion of edge of space, and we have reached space, guys.
Congratulations,
Hello, sir.
Vikram-1 is in space.
हमारा यान अंतरिक्ष
Plus 3
तक पहुंच चुका है.
And we've had callouts of separation of the payload fairing. We have successful payload fairing separation.
It's
Payload-
nearly at an altitude of 120 kilometers, and the protective fairing is no
S2
longer required
separated.
and has been cleanly separated from
S3
the launch
motor
vehicle.
ignited.
और यहाँ पे द्वितीय चरण का भी प्रतिकरण संपन्न हो चुका है और तृतीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
That's right, Akhil. We've had successful ignition of stage 3. The vehicle is currently at 157 kilometers above the Earth's surface. It is 355 kilometers downrange, traveling at nearly 4 kilometers per second. Now, the
S3
telemetry
performance
will
normal.
switch over from Shar to Port Blair and further to Bogor.
अब यान अपनी अंतरिक्ष यात्रा पर निकल चुका है. तृतीय चरण का प्रज्वलन चालू है और उसकी
Plus 4 minutes.
प्रतिक्रिया नियमित रूप से चल रही है.
And as you can see on your screens, we have near exact following of the intended trajectory. The two dotted,
SVP
the two
Valentu
lines
are
on your
tracking in main
screen
auto.
essentially indicate the current performance of the vehicle, and it closely matches with prediction. This is on your screen on board from stage 3. What you see is the rocket plume and the nozzle, and Earth, our home.
What a beautiful view. क्या सुंदर दृश्य है हमारी पृथ्वी का.
S3 performance normal.
और तृतीय चरण का परफॉर्मेंस अब नॉर्मल है या कि सामान्य रूप से तृतीय चरण का संचालन प्रारंभ हो चुका है और चल रहा है.
That's right. We've had call out that the stage 3 performance is nominal.
Plus 5 minutes.
So stage 3 has a propellant loading of 2.5 tons, and we've had burnout of the stage 3 motor as planned at
S3
T plus
burnout.
5 minutes. Yes, we've gotten confirmation that S3 has burnt out, and now we're entering a planned coast period. something that lasts for 140 seconds, in which it's called as combined
Combined
coast.
coasting is normal.
Right, so we've got call out that the combined coast is nominal. This will last for roughly 140 seconds, where stage 3 is not producing thrust, but it's connected to the vehicle and it's going to coast as a single body. All of this is done to manage the altitude of the vehicle and also control where the stage will re-enter the Earth's atmosphere before splashing in international waters
Plus
in a
6
safe
minutes.
and planned manner. And jubilant views from the launch control center, where the teams are extremely elated and excited.
और मिशन नियंत्रण केंद्र और लॉन्च नियंत्रण केंद्र से आपको दृश्य दिखाई दे रहे हैं। सभी यान परीक्षण दल अत्यंत ही प्रसन्न हैं और यहाँ पर जो प्रसंग है वो एक उत्सव का प्रसंग बन चुका है, एक ऐतिहासिक क्षण भारत के निजी अंतरिक्ष उड़ान का। विक्रम-1 यान अब अंतरिक्ष में स्थापित हो चुका है। तृतीय चरण अब अपने कोस्ट फेज पे है और ये कोस्ट फेज अभी आप कैमरा व्यूज देख सकते हैं अपने प्रक्षेपण पर्दों या मोबाइल स्क्रीन्स पर, जहां पे आपको धरती का एक सुंदर दृश्य दिखाई दे रहा है।
As we can see on our screens right now, it's really amazing to see that Vikram-1 as of now is going along its intended trajectory exactly as expected. Our plots are really overlapping. The predicted velocities and the current flight velocities are exactly matching. And aren't you guys speechless right now?
I mean, मेरे पास शब्द ही नहीं है, मतलब ये मैं निशब्द हो चुका हूँ।
That's right. We are approaching another point wherein S3 will separate.
S3 is separated.
और तृतीय चरण का प्रतिकरण भी हो चुका है।
And you see wonderful views of S3 separating. And now we have combined coasting has ended, and stage 4 will now coast on its own for the next 130 seconds. So stage 4 will now fly on its own, essentially. And
the control thrusters on the OM will be
S4
continuously
posting
turning
normal.
on and off to maintain the attitude of the stage, making sure that it is pointing the right way. This also ensures that the antennas can maintain connection with the ground station and the satellite can be pointing in the right direction.
That's right. So one unique thing that has been done during separation is we've essentially fired all 4 of our Raman Mini thrusters to sort of push stage 4 away from stage 3. And that just sort of guarantees that there is some minimum separation between the two.
अब आने वाला जो चरण है वो द्रव्य प्रणोदन पर आधारित होगा, जिसको हम कक्षा स्थापन या समायोजन खंड ऑर्बिट एडजस्टमेंट मॉड्यूल के नाम से भी जानते हैं, जिसमें द्रव्य प्रणोदन की अवस्थाओं से संचालन होगा जो मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टाइट्राऑक्साइड पे आधारित है।
9 minutes.
उसके साथ यान के घूर्णी नियंत्रण के लिए, जिसे कंट्रोल थ्रस्टर्स कहते हैं हम लोग, उन रामन मिनी 50 न्यूटन, वो भी मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टेट्रा ऑक्साइड पर ही आधारित है। उसके अंतर्गत हमारे पास छोटे कोल्ड गैस थ्रस्टर्स जो कि नाइट्रोजन गैस पर आधारित हैं, वो भी कक्षा समायोजन खंड पे स्थित हैं।
S4 ignited.
And we've heard call out that S4 or stage 4 has ignited successfully.
और चतुर्थ और अंतिम चरण का भी प्रज्वलन हो चुका है।
The liquid engine has come alive over 400 kilometers above the Earth, beginning a burn that will last for more than 6 minutes. During this phase, the vehicle will steadily accelerate from about 6.68 kilometers per
10 minutes.
second to nearly 7.64 kilometers per second, delivering the precise velocity needed to achieve its planned 450 by 450 kilometers circular low Earth orbit at a 60-degree inclination.
और यहाँ पे आप देख सकते हैं कि प्रक्षेपण नियंत्रण केंद्र में उत्साह का एक प्रसंग आ चुका है और आपके ऑन बोर्ड प्रक्षेपक पर्दों पर हम देख सकते हैं कि पेलोड्स या जो उपग्रह हैं उनका एक चित्र, यहाँ पे सारे उपग्रह अपने स्थान पर स्थित हैं.
That's right, Akhil. We've also had seamless transition from the
S4
Port Blair
performance normal.
to the Bogor station, and now we are receiving strong telemetry from the Bogor as well as the Yatharga stations in Indonesia and Australia,
Plus 11
respectively.
minutes.
The current altitude of the vehicle is 426 kilometers. Our target is near 450. We're traveling at 6.5 kilometers per second. And like we said earlier, OAM is essentially going to fire its Raman-2 engine for a cumulative burn time of nearly 6+ minutes. So this is the longest burning. It's the smallest in thrust, but it burns for the longest period of time. And it's all given to us by Raman-2, our main engine for this mission.
So Yash, it must be a really amazing feeling, right? I mean, you and your team worked on this engine to get it going, and it is finally taking us to space.